Hi, so when do we need IV estimation? Well, if y is a function of x and x is not exogenous, or in other words, is endogenous, so there's something hidden in the arrow term that makes x endogenous. In such a case, we need an instrumental variable. To make it more concrete, if y is wage, and wage is a function of education, so this is the typical Mince equation approach, so we'll have that in more detail during this lecture, then you might argue that education is endogenous. And what does that mean? Well, there is something hidden in the arrow term, that is correlated somehow with education. And that could be, for example, IQ. So IQ has an influence on the years of schooling you take, and this could be positively or negatively correlated, but there's something hidden in the arrow term that is correlated with education, and then in such a case, you cannot take education as exogenous variable. Another way to put that is exogeneity requires that the covariance x epsilon, and epsilon stands for the arrow term, is 0. However, if covariance x epsilon is not 0, then we talk about endogeneity. And the covariance, right, between x and epsilon could be positive or negative. And the covariance between the explanatory variables x and the arrow term is then crucial for endogeneity bias. So if covariance x epsilon is not 0, we talk of endogeneity bias. And in case of endogeneity bias, one of the Gauss-Markov conditions is violated so that you cannot use OLS to identify a causal effect. Using IV is using a non-experimental approach to identify a causal effect. So the experimental approach is the randomized controlled trial. Non-experimental approaches are, for example, diff and diff. So we were very detailed on that in a previous lecture, and another non-experimental approach would be then IV. And both run under the label of a natural experiment. Natural experiment means that there is an exogenous variable, an exogenous variation in a variable. We had examples like exogenous variation of a variable. So this was the introduction of the minimum wage. So this is the famous Cart-Kruger 1994 minimum wage study. We also had an exogenous variation in a variable, that's the Mariel boat lift. So both are exogenous variations in a variable, and then you have a before and then you have a after view. So this is the diff and diff approach. And now another way to put a natural experiment or do measure a causal effect in a natural experiment is the IV. And I will come to the IV in a second, but let me highlight that IV requires a non-testable identifying assumption. Like all these evaluation methods need identifying assumption that allow to disentangle the selection from the causal effect. Here, the non-testable identifying assumption is also called the exclusion restriction. Intuitively, that means that you exclude the causal effect from the selection effect, and so you exclude the direct causal effect on outcome. We have two conditions for an instrument. The first condition is the so-called exogeneity condition that cannot be tested. So you have to argue that this exogeneity condition holds. You cannot prove it. So endogeneity would be that there is a correlation between the instrument set and the error term. So in the error term here, I denote the error term u. I could also say it's epsilon, right? So you need an instrument that has no correlation with the error term and with hidden elements in the error term. So this is easier to understand if you make it a little bit more concrete, right? So take once again the Mince example, because we will dig deeper here and also using an R session for that. So if y is the wage, and here the D stands for education, so that's a kind of X variable, and D is maybe a dummy variable, right? You have education, yes or no. So at least that's something that is explanatory, right? And if you argue that education is not exogenous, it's endogenous, because there is something hidden in the error term, and let's say, to make that concrete, the hidden in the error term is the IQ that is correlated positively or negatively with education, then you need an instrument that is correlated with education, but has no effect via the error term on the outcome variable, and that's highlighted here, right? So you need an instrument that has no effect via the error term on the outcome. Just to take an example here, assume now that college, proximity to college is, so the distance you live to college is correlated with education, right? But then you should argue, and you cannot prove that, you can just argue that college proximity is not correlated with IQ that is hidden in the error term, so that there is no effect via IQ on the outcome, and the outcome is, in case of the Mince equation, wage. So this sounds a bit weird, and at least when you hear that the first time, the exogeneity condition, you just have to read a couple of papers to understand what it means, that you try to convince at the end of the day the referee that the exogeneity, that condition that cannot be tested, is not violated if you use an instrument like that. And that's what the literature is about. You argue that your instrument has no direct effect on the outcome variable, or to be more precise, has no indirect effect via the error term on your outcome variable, and therefore it's that's something you have to argue, right, in order to be allowed to identify a causal effect via IV. So take your time. This will take some time to understand what's going on here with IV, but that's now the first approach to understand or to go through the exogeneity condition. Just one more thing here, the relationship between the instrument and y should not exist, right? If you now take college proximity to college as an instrument that has an effect on years of education, right? That has an effect on years of education. That's okay. However, the instrument should not directly be correlated with wage, right? That's the complicated thing. You need something that is correlated with the endogenous education variable, but not here directly with wage. And that's not that easy to argue, so it's hard to find instruments that are convincing, and smart people try to find, of course, some arguments that there is a relationship between Z and Y, just to kill the IV approach, and that's what discussion is pretty often on. Is there really no relationship between instrument and the outcome variable? Just to have that in mind when we go through some papers later on. A second condition for an instrument that there is a relationship between the endogenous variable and the instrument that can be tested. So you could have either a positive or a negative correlation between the instrument and the endogenous variable. Let's say the endogenous variable is education. So then you need an instrument that might influence education positively or negatively. We'll see a couple of examples for that. For example, proximity to college could be maybe an instrument that is positively or negatively correlated with the years of schooling.